Hi, my name is Conrad Jensen. I'm just going to walk you through today some basic calculations on resistance, current and voltage. So as you can see over here, we've got currently a simple circuit, and this simple circuit is powered by a 20 volt DC supply, and we know that there are two resistors, 10 ohms and 10 ohms. Okay, so how we'd normally calculate the total resistance in series, we just add it together. So 10 plus 10 is 20. I want to get some calculations down in the middle of the circle here, middle of the circuit here, and we'll work out what's what. So first of all, total voltage, and that would equal 20 volts. And then of course we've got the total resistance, which we now know to be 10 plus 10, 20 ohms. So to calculate the current, we simply use this particular formula over here. So we've got 2 out of the 3, which we do. Currently we've got the voltage and we've got the resistance. So to get the current, we'd need to divide the voltage by the resistance to equal the current. So 20 over 20, pretty straightforward and easy sort of calculation there, gives us a total current of 1 amp. 1 amp. So now that we have that, we've completed the totals. What else can we find out from this particular circuit? Well, what we can find out from this particular circuit is what they call the voltage drop. So how much voltage is dropped over R10? How much voltage is dropped over this R10? Well, again, you can use Ohm's law. So we've got 20 volts. Okay, 20 volts. And to find out what is the voltage drop, we simply divide that by the amperage. So 1 amp divided by 20 volts, and what we got over here is, the answer is 20. But that's in total. What we're going to look at is the individual sums over here. How much voltage drops over this one, how much voltage drops over this one. So if we look at it and we go looking back at the triangle, we go R times I equals the voltage. That gives us a better clue. So we know that I is 1 amp. No matter where it is in the circuit, it's always going to be 1 amp. It's constant. In series circuits, the current is constant, because in a series circuit we call it a voltage divider. When it's in parallel, which we're going to show you in the next example, it's called a current divider. So if we divide, or multiply I should say, the resistance multiplied by the current, so it's 1 times 10, that would give us 10 volts. Well, let's put that in there, makes sense. So that would be 10 volts there, and of course if it's 10 volts there, it's the same calculation, so it would be 10 volts there as well. So we know that there is 10 volts dropped equally here because the resistors are equal, so therefore the voltage drop is equal over each component, so 10 plus 10. Let's have a look at the same circuit, but this time we've rearranged it. So we've still got two 10 ohm resistors and we've still got a 20 volt power supply. But how does that affect the numbers now? Because before I told you that the series circuit, as having one resistor after another one in a series in a circle, we added the resistors, but in this instance we don't add the resistance. We basically need to invert the numbers, and then of course after we've done that we can add them. So basically to calculate the total resistance, we would have to put a little line over this one, a little line over this one, and invert these resistance values. So 1 over 10 gives us a value of 0.10, if you like, and we're going to add that with 0.10 to come up with a value of 0.20. Okay, so 0.20, but remember it's 1 over. So 1 divided by 0.20 would give us a total resistance of 5 ohms. So just looking at that again, we do sort of still add these things because we've still got this add function. But the add function isn't just a pure add function, we need to invert the numbers. And then of course at the end of the day we also invert this as well to come up with a total resistance, which is 5 ohms. So now we've got total voltage of 20 volts, total resistance of 5 ohms. So let's see how that affects the current now. So R total, 5 ohms. Voltage total, it still remains the same at 20 volts. The difference between the previous series circuit and this parallel circuit is we classified this as a current divider and not as a voltage divider. So no matter where we measure the voltage, it's always going to be 20 volts in this instance. There's no voltage drop over the resistors. And it seems a bit odd, but what basically happens here is the current, instead of having a single route, it's got 2 routes now. So we expect that the current would be changing over the capacitors in this particular circuit. It's got 2 routes. So let's put that in now. So how do we calculate the total current? Well, we know that the total current in the whole circuit is 20 divided by 5. And what's 20 divided by 5? Well, basically that's 4 amps. But how are those amps distributed across these particular components in this circuit? If we were to measure it, of course there will be 2 amps going down this route and another 2 amps going down this route, giving you a total of 4 amps. So again, we've come up with the solutions to a couple of problems here where we've worked out, first of all we found out what the voltage was, and then we worked out what the resistance was, and now we've worked out, of course, finally the total current, and the current being different over the 2 resistors in a parallel circuit. So that's basically series and parallel resistors. And thanks for watching. Hope this was helpful.